Students, let's see new number from exercise 15.1, question number 19. See the first of all question. A child has a dice whose 6 faces, so the letters as given below. 6 faces are not numbered, but they are letters A, B, C, D, E and A. The die is thrown once. What is the probability of getting A, and second is D? The first of all, a die has a 6 surfaces. Let us write total number of outcomes. Total number of outcomes is equals to 6. We need to find first probability of getting A. The first, let A be the event that on one throw of dice getting A. See, in the faces there are 2 faces of letters A. Therefore, number of outcomes favorable to this event A is equals to 2 faces containing A. Therefore, the favorable outcomes are 2. Event is A, then its probability denoted by P of A. First of all, we have to write formula at first time. Number of outcomes favorable to event A upon total number of outcomes. Now we know the favorable outcomes are 2 and the total number of outcomes are 6. P of A is equals to 2 upon 6. 2 3s are, then our answer of probability is 1 upon 3. 1 upon 3 is the probability that the letter getting on dice which is A. Now second is D. First of all, we have to assume one event. Let B be the event that same sentence will be repeated here. On one throw of dice getting the second letter which is D getting D. Therefore, the number of outcomes favorable to event B is equals to only one surface has a letter D, that's why the number of favorable outcomes is equals to 1. D is our event, then its probability is denoted by P of D. P of D is equals to number of favorable outcomes is 1 and upon total number of outcomes, the total number of outcomes are 6. Then our answer of probability is 1 upon 6. Here 1 upon 6 is the probability that the letter getting on the face of dice which is not A but D. Here 19 number is completed. Now see the 20th number. 20th number given in given in our textbook is a start form. Is not asked in our examination but is somewhat important. That's why we have to complete it. Suppose you drop a dice at random on the rectangular region shown in figure 15.6. One figure is given. What is the probability that it will land inside the circle with diameter 1 meter. The dimensions are given. Rectangle has a length and breadth and circle has a diameter. So first of all we have to write dimensions for rectangle. Length is equals to 3 meter and breadth is equals to 2 meter, and the diameter of circle is given. Diameter of circle D is equals to 1 meter, therefore radius R is equals to 1 upon 2 meter or 0.5 meter. The figure is not required here, but we need to find probability that a dais will land inside the circle. Dais will land inside the circle, but it has a total surface area of this figure is denoted by a rectangle. Means what? The total number of outcomes we have to take as the area of rectangle, and as a favorable outcomes we have to take area of circle, because question says that a dais will land inside the circle only, not whole part but inside the circle only. That's why we have to take total outcomes as a area of rectangle and favorable outcomes as a area of circle. So first of all we have to find both areas. Area of rectangle is equals to length multiply breadth, where length is equals to 3 and breadth is 2. 3 2s are 6. Unit is meter square for area. Now area of circle. Area of circle is equals to formula pi r square, where pi is not given, then we have to take 22 upon 7. Now figure is not required. Instead of radius r, 1 upon 2, 1 upon 2, because r square is here. One time cut is possible. 2 11s are numerator. The multiplication of numerator is 11 upon 7 2s are 14 meter square is the area of circle. Now we have to assume one event. Let A or E, right now A be the event that dais will land inside the circle. For that we have to write number of total and a favorable outcome as the area of rectangle and area of circle written above. Therefore the probability P of A is equals to, instead of number of favorable outcomes and number of total outcomes in this sum, we have to write as the favorable outcomes area of circle upon area of rectangle, where area of circle is equals to 11 upon 14 upon area of rectangle is equals to 6. Area of circle is 11 upon 14 and area of rectangle which is 6. Now shift 11 in the denominator is equals to 11 upon 14 into 6. Here the cut is not possible, that's why we multiply 14 by 6. 11 as it is. Probability of an event 14 6 are. If you are not able to do directly, do multiplication. 14 into 6. 14 into 6 gives us 84. P of A is equals to 11 upon 84 is the probability that the dais will land inside the circle. 20th number is somewhat important, not for examination point of view, but it is not difficult sum which is a very easy. Now we see the next number from our textbook. Let's see the new next number, question number 21. A lot consists of 144 ball pens, of which 20 are defective and the others are good. We don't know the other numbers which are good. Nuri will buy a pen if it is good, but it will not buy if it is a defective. The shopkeeper draws one pen at random and gives it to her. What is the probability that first she will buy it and second she will not buy it? It is our question. A lot consists of total 144 ball pens. A lot consists of 144 ball pens. There are total 144 ball pens. Therefore, the number of total outcomes. Therefore, number of total outcomes is equals to 144, in which given that 20 are defective ones, means the number of defective ball pens is equals to 20. A lot consists of 144 ball pens, which 20 are defective one and the other are good. Therefore, first of all, we need to find number of good or non-defective good ball pens is equals to total 144 minus 20 are defective gives us good non-defective ball pens. 144 minus 20 gives 124. 124 ball pens are good which are not defective. Now first of all we need to find two probabilities and we have to assume one event as a E. Let E be the event that pen will bought by a person. A person is a Nuri. She will buy it, means pen is bought by a Nuri. She will buy the ball pen. According to the question, Nuri will buy a pen if it is good. Nuri will buy a pen which is good. Therefore, the number of good ball pens are 124. 124 ball pens are like to buy a Nuri. Therefore, number of outcomes favorable to event E is equals to the number of favorable outcomes. The pens are good 124. E is event, then its probability is denoted by P of E is equals to formula number of outcomes favorable to event E upon total number of outcomes. The number of outcomes favorable to this event, which is 124, but total number of outcomes are a lot consist of 144 ball pens. The total number of outcomes are 144. Now the cut is possible. Both are even numbers by 2, 2. If you are able to do directly, then cut it directly. By 2, 2. 62. 72. Again both are even numbers, then again cut is possible by 2, 2. 231s and 236 are. Now cut does not possible. That's why the probability of this event P of E is equals to 31 upon 36. 31 upon 36 is the probability that Nuri will buy a pen. Now the next probability, second number, let F be the event that she will not buy a pen. She will not buy a pen. Again in question, but will not buy a pen if it is a defective. Nuri will not buy a pen when the pen is defective. Then we need to find number of defective ball pens. The number of defective ball pens are 20. Therefore, the number of outcomes favorable to event F is equals to, we have to take number of defective ball pens. Number of defective ball pens are 20. Therefore, the probability of an event P of F is equals to favorable outcomes are 20 upon total number of outcomes are 144. Again by 2 cut is possible, 2 tens are, and here 72. Again one time cut is also possible, 2 5s are and 2 36 are. Therefore the probability of event P of F is equals to 5 upon 36. 5 upon 36 is the probability of an event when Nuri will not buy a pen. Now see the two probabilities here, two events. C will buy it, C will not buy it. Both are which type of events? Complementary events of each other. So that in the second number we have to use our concept of complementary events like this. We know the probability of an event E. P of E plus P of E bar is equals to 1. Instead of second number we have to also use complementary event. The concept of complementary event. We know the P of E. P of E bar gives us she will not buy a pen. We know the P of E probability is 31 upon 36 plus P of E bar is equals to 1. Now we have to make P of E bar as a subject. P of E bar is equals to 1 minus 31 upon 36. By taking LCM we have to solve it and we get our answer 5 upon 36. 36 ones are 36 minus 31. 36 minus 31 is equals to 5 upon 36. 5 upon 36 is the probability that she will not buy a pen. It is also possible using the complementary event. In this session we completed up to question number 21. 21 is not so difficult. In homework, if you have any query, then tick mark it. Whenever we meet, we can solve it probably.